let's work through some details of this problem. Okay, so in the problem, the diagram is given to you something like this. It's a triangle, and then it has a 2, a 1, and a 4 marked in there. Okay, so it's a little bit tricky because it looks like it's labeling the length of those intervals, but it actually says those are the ratios of the lengths of those intervals. So those are not actual lengths. And then so that's all that was actually given. But it also tells you that it's an equilateral triangle. So I could mark in that these are all 60s. And it also says these are actually perpendiculars. Okay. And so, given this information, and it's equilateral, I haven't marked that the lengths are all the same yet, but so the question is, if this quadrilateral is 13 centimeters squared, what is the area of the whole triangle? Okay. So when I look at this, I'm thinking similarity. Similarity is going to come into this somehow, because I don't actually have the lengths. I have the ratios. Okay. And so I know something about similarity, as in I know if two things are similar and the lengths are doubled, the area will be quadrupled. Okay. So I know that. So, and I know how similar triangles work. I know that they're similar if the angles are the same, but how does similar quadrilaterals work? So that's something we might have to figure out. So if we look at this shape, 60 degrees here. That means this has to be 120. And the ratio of those sides is 2 to 1. Okay. So if we drew this thing instead of 2 to 1, we drew it 4. Draw it 4 and 2. Okay. And we know that's 120. So we know that there's only really one way to have that the same. So that part, half of the triangle is similar. But then if we fix this angle to be 90 degrees, okay, that also fixes where the last point has to be. Okay. So these two quadrilaterals are actually, okay, I've drawn them pretty badly, but they're actually similar. So we don't actually know what the actual other side lengths are. We don't actually know what those side lengths are. We just know the ratios. And that's enough to say that the area, if that's 13 centimeters squared, and this is everything's bigger by a factor of 2, okay, then the area here, it should be 13 squared. So 4 times 13 centimeters squared. Okay, so that's 52. And then now it's a question of what this last quadrilateral is. So the problem with this 1 and 4 business, it makes it not similar. But if we extend this by 1 and make this parallel to this side, then this extended shape is actually equal to the 52 centimeters squared. So we just got to figure out what these are as a fraction of that, and then so what this is a fraction of the whole thing, and then times it by 52. So one way to do this, you could probably imagine another parallel line. So this is all 90, and this will be 30, 60. I think we actually have enough information to figure all that out.